So I think the exciting developments with Forma incorporating now this embodied carbon analysis is that it allows for much more dynamic interactions among the architects and the rest of the project design team members. So really, we can sit together and look at the same model because it's cloud-based. We can do it remotely even. And really look at, like, okay, if you make these design decisions, this is the impact on the embodied carbon. We can run the analysis, we can interpret the results live, and then run some iterations. So we'll go over some of what we've done on the sample project here. It's a large-scale redevelopment, transit-oriented development project we're working on here in Metro Vancouver. Of about 20 plus towers that are going in on an infill commercial site. The developer approached us and really wanted to explore what was possible on this site, and to begin the process of looking at master planning across the site. And we developed a package and looked at some renders to kind of show them what was possible. Introducing a new park and several towers. So it's about 25, 26 towers proposed in the current iteration. Most of those are residential with a commercial or retail component on the ground floor, as well as there's a hotel component. The team went through and did quite a bit of analysis looking with Forma, looking at what was possible from different massing, different height options, looking at the impacts through sections. So being able to pull all of these kind of early concept drawings straight from Forma, looking at shadow study, being able to do solar and wind and these kinds of things. We kind of went through what we would normally go through on a embodied carbon analysis and a whole building LCA. On this case, we're looking at a whole neighborhood LCA, but we built out our baseline, looked at a hybrid concrete structure for high rise as kind of our assumption. We looked at a GFRC cladding as kind of a typical practice in this region, and 50% window to wall ratio. And then, as I mentioned, it's a mixed use residential and commercial. So we set all of the majority of the buildings to a residential use. We were able to select the way we had built up the model, select the podium separately and set those to a commercial use, as well as there's one commercial tower kind of at the center and a hotel, which we set to a residential use. Diving in as a first-time Forma user, I think I was given access to the model, and making all of those adjustments took me maybe an hour and a half, something like that, to kind of get familiar with the tools and go through and select the buildings. You're able to select multiple buildings and change the features. So it was pretty quick. And then, as you can see on the right hand side here, it's 5 to 10 seconds to run the analysis. So we're able to click on that button and we get our results. So this highlights in the color gradient the relative embodied carbon impacts of all of those buildings. And we can see I've blown it up a little bit here on the right hand side, the results. So the total embodied carbon for all of the buildings, 723,000 tons of CO2. So it's a not insignificant amount given the scale of the project. Not too surprising. And then the average carbon. So this is what sometimes we refer to in the industry as well as carbon intensity, if you're not familiar, which is a per square meter evaluation. So it gives us an ability to compare buildings of similar types to say, okay, per square meter, this building has a higher carbon intensity than this other one. So across the whole site through all of the buildings, we see we have an average carbon intensity of 409 kilograms of CO2. As a baseline, it gives us now a number that we can compare to. And that's really where the power of early modeling for embodied carbon is so useful to teams, to be able to say, okay, even if I know, and I know like some of these assumptions, I'm still able to use this model to compare. If I substitute materials or look at different design options, then I can say, okay, relative to, my baseline, this version is performing better. For learning purposes, basically, we said, okay, let's look at the shortest few towers, assuming that, building code in the province might catch up. So we have these three I've highlighted here in the lower left are the office tower, actually, and one residential tower and the hotel. And they're 35, 40, and 28 stories, respectively. So let's change the structural systems in Forma and see what our relative impacts would be. You can't quite see it. I didn't highlight it here, but the average carbon for just these three buildings is 313. So quite a bit below our total average across the whole site. But it's exciting now we can actually see across the whole site, how does just changing those three buildings impact our total embodied carbon. So we see that the results here at the bottom right. The total tonnage has dropped to 681,000 tons approximately, and the average carbon, which is the carbon intensity, has dropped 394 kilograms. So about a 15 kilogram per square meter drop across the whole site just from shifting those three towers. And if we look at the total carbon saved, it's 42,000, just over 42,000 tons of CO2 saved. So it's quite a significant, we're looking at a very different scale than maybe a single building if you were doing this analysis, but you're able to I think, really appreciate the measures or the significant impacts that, some of these design changes can have at an early stage. So it was really great to be able to dive in and use the tool in this way and start to, have these conversations with the design team, and the client is also very excited to kind of hear some of these results. So, where do we take it from here? We have a few of these embodied carbon stars in the firm across several of our offices, and we're really excited, I think, to take what we've learned on this project, and we're working on many other projects in Forma right now. So to be able to help educate both our embodied carbon and sustainability teams, as well as the design teams on the tool, and hopefully apply it in many more use cases.